Okay students, we are again meeting here for the next episode, that is absorption spectroscopy and emission spectroscopy. Now absorption spectroscopy, it is the light, it depends on the light that is absorbed, okay, by the molecule. Now here this absorption spectroscopy is having two laws which govern it. The laws are Lambert's law and Beer's law. Lambert's law, thicker the medium, more is the absorption of the light radiation. And Beer's law, it tells that the higher the concentration of the liquid or the solution, the lesser will be the emergent light intensity. Now, how we have achieved these two laws, how we have proved it, is that first of all we have taken a chamber, and if this chamber, from this chamber, we have taken a very small part of it of length dx. Now the path length is what? Path length is dx. Now here the light that is incident is having an intensity of I0, and the emergent light is having an intensity of I, and I is less than I0. So therefore some amount of light has been absorbed here, and this light that is absorbed is I0 minus I. So here we will be calling this part as dI is equal to I0 minus I. Now this I0 minus I depends on what? We have already informed this part. It is what? It is dependent on the concentration. So what is the concentration? It is Nc. And what is the thickness of the sample? The thickness of the sample is S square dx. That is the volume of the sample. Okay. So thickness is dx, S square into dx. So here when we go for the light absorbed, so light absorbed is di, and the fraction of light that is absorbed is di. Di is proportional to di by I is proportional to n square c at dx. Okay. So what is the proportionality constant? It is k dash. Now from here, this can vary depending on case to case. So this can vary, but if k is a constant and Avogadro's number is a constant, and the area of the sample, that is this area, okay, on which the light is focusing is constant, then all these three are constant, and which we can together come out to a single constant, that is minus a. Now here what we get is, after integrating this, what we get is after integrating this, we get it as ln IB. Why it is B? Because this I, that is transmitted light, is dependent on the thickness of the plane. Okay. Now thickness here from dx we have taken the total thickness, that is 0 to B. The total thickness is B. So therefore it is IB is equal to IB by I0 is equal to minus ACB. I hope it is clear. So please take a pen and paper to work it out along with the discussion. If you have any doubts, please feel free to ask. The diagram below shows a beam of monochromatic radiation of radiant power I0 directed at a sample solution. The absorption that takes place and the beam of radiation leaving the sample has the radiant power of I. That is, radiant power is patterned by the intensity of the emergent radiation. Okay. So here transmittance is what? Transmittance is the fraction of the light fraction of the intensity of the light, okay, of the transmitted radiation. So what we have here, it is T is equal to IT by I0. Okay. So So percentage of transmitters is simply multiplied by 100. Okay, now what absorption? Absorbance what we have is A is equal to log to the base 10 I naught by IT. Now we know I naught by IT here can be written as 1 by T. Okay, so 1 by T, what we can write it as log A is equal to log 10 I by T. Now, if you multiply both sides by 100, this is the thing, and then we can work it out as 10 to the power 10 to the power 2 is equal to 100, and this power 2 we know it can be taken as initial, and it comes to be 2 minus log 10 percentage of T. Please work it out along with this discussion, and if you have any doubt, please feel free to ask. Now, there is a relation between percentage of transmitters and absorbance. Now, what is that relation? We can work it out. If all the light passes through a solution without any absorption, then we say that the absorbance is 0. The percentage of transmitters is then 100%. If all the light is absorbed, then the percentage of transmitters is 0 and absorption is maximum, that is, it can be infinity. Okay, now if we go into a observation, we find that at 0 path length, percentage transmitted is 100, and then we have 0 absorbance. Okay, now if the path length increases, that is 0.2, then what we see, there is a change in transmittance, and it becomes half of it. Now if at 0.4 it becomes further half, at 0.6 it is becoming further half, and 0.8 it is becoming further half, and it is 1.0 it is becoming further half. Now what is the relation between that? We can understand that the percentage of transmitters and the path length has got an exponential relation, and it increases and it decreases with the increase in path. It decreases with the increase in path length. Okay, and the absorbance is also having an increase, and it increases exponentially with the it increases linearly with the absorbance. Okay, and so let us check it out with the graph. See this? So here what we see is, please work it out with this discussion LT, and you have to take LT and B in a relation. Okay, and you will find that it is having an exponential relationship with B. Okay, and but when you take it as with a constant, you find that log I naught by IT, it is having a linear relation, just like y is equal to mx, and m is the slope of the line, and therefore we have a linear relation. But when you take IT and B, you will find that there is a exponential relation. So just remove log. When you remove log, you will get I naught by IT is equal to 10 to the power B. Okay. Now if you reverse it, you will get 10 to the power minus B, and that is what it will be decreasing. And IT will be is equal to L and I naught 10 to the power minus B. Then it will decrease exponentially. Okay. But definitely you have to remember that at concentration remaining constant, when concentration remains constant. Similarly, when you take concentration changing and the path length is constant, you will find this is the relation, and accordingly the same type of graph will come at the end. So I hope you don't have any doubt on this. Already worked it out. So now we are combining both of the things, and A is called the absorptivity. Okay. Now what is the unit of this? This path length is 1 centimeter and concentration is 1 gram per liter. We have A is equal to absorbance. Okay, absorptivity is equal to absorbance. Now we have another term which is called molar absorptivity or epsilon. What is the relation between A and epsilon? Just see this relation and accordingly take a pen and paper and accordingly work it out on your own. If you have any doubt, because this relation you will be needing, this unit you will be needing, if you have any doubt, please feel free to ask. In case of absorption spectroscopy, you should always remember P is less than P0, that is I is less than I0. Therefore, it is a fraction and it is less than 1, and the percentage is also less than 100%. We've already worked it out. So you can see this diagram below. So here, if you see, the thickness is increasing. Thickness is increasing. So with the increase of thickness, you will find here the thickness is increasing. Okay, and thickness is increasing. Sorry, not the thickness, but the concentration is increasing. So when the concentration is increasing, you can see the transmittance is decreasing. Okay, so that's all for now. So please feel free to ask if you have any doubt, and try to take a pen and paper while hearing to this lecture. Thank you.